An isosceles trapezoid has special properties. This concerns its pairs of base angles, pairs of opposite base angles, and its diagonals. Quadrilateral ZOID is an isosceles trapezoid because its legs are congruent. The pairs of base angles of quadrilateral ZOID are angles Z and O and angles D and I. A theorem states that the base angles of an isosceles trapezoid are congruent. Therefore, we can say that angle Z is congruent to angle O and angle D is congruent to angle I. Let's have examples. If the measure of angle D is 87, then what is the measure of angle I? Based on the figure, angles D and I form a pair of base angles, and based on the theorem, the base angles of an isosceles trapezoid are congruent. We can therefore say that angle I is also 87. The second example is, if the measure of angle Z is 93, then what is the measure of angle O? Based on the figure once again, angles Z and O form a pair of base angles. Therefore, angle O is also 93 degrees. Let's have the third example. If the measure of angle DZO is 2x minus 10 and the measure of angle IOZ is 3x minus 70, let's find the value of x and the measures of angles DZO and IOZ. We now solve for the value of x. Based on the given, angle DZO and angle IOZ are 2x minus 10 and 3x minus 10 respectively. As you can observe, angle Z and angle O form a pair of base angles, and base angles of an isosceles trapezoid are congruent. We then have the equation measure of angle DZO is equal to the measure of angle IOZ. Based on the given, angle DZO is 2x minus 10, and that is equal to the measure of angle IOZ, which is 3x minus 70. So we need to copy 2x from the left. Then from the right, we need to transfer 3x to the left. It becomes negative 3x. And that is equal to, we copy 70 from the right. Then from the left, we move negative 10 to the right. It becomes positive 10. So we simplify both sides of the equation. It becomes negative x equals negative 60. Multiplying or dividing both sides of the equation by negative 1, the value of x will be equal to 60. We now solve for the measure of angle DZO since we already have solved for the value of x. Based on the given, once again, the measure of angle DZO is equal to 2x minus 10. All we need to do to solve for the measure of angle DZO is to substitute the value of x, which is 60, to the variable x in the equation. We have measure of angle DZO is equal to 2 times 60, which is x minus 10. The product of 2 and 60 is 120 less 10. The difference is 110. The measure of angle DZO is 110. We now solve for the measure of angle IOZ. Measure of angle IOZ is equal to the measure of angle DZO since these two angles form a pair of base angles. Since the measure of angle DZO is already solved, we have 110. Then the measure of angle IOZ is also 110. The opposite base angles of an isosceles trapezoid are supplementary, meaning the sum of the measures of the two angles must be 180 degrees. Angles Z and I in quadrilateral ZOID are opposite base angles. Therefore, their sum is equal to 180 degrees. The same is true for the measures of angles D and O, which are also opposite base angles of quadrilateral ZOID. It must also be 180 degrees. Let's have examples. If the measure of angle Z is 111, then what is the measure of angle I? Based on quadrilateral ZOID, angles Z and I form a pair of opposite base angles. Therefore, the sum of their measures is equal to 180. We need then to subtract 111 from 180, and that leads us to the measure of angle I, which is 69. If the measure of angle D is 60, then what is the measure of angle O? Based on the given figure once again, these two angles, D and O, form a pair of opposite base angles. Therefore, their sum must be 180 degrees. Since angle D is 60 degrees, all we need to do is subtract 60 degrees from 180 degrees, and that is 120 degrees. The measure of angle O is 120. The third example is if the measure of angle DZO is 10y plus 48 and the measure of angle OID is 12y minus 22. Let's find for the value of y, the measure of angle DZO and the measure of angle OID. We are now then ready to solve for the value of y. We then have the measure of angle DZO plus the measure of angle OID is equal to 180. So we are given the measure of angle DZO, which is 10y plus 48, and the measure of angle OID, which is 12y minus 22. By substitution, we have angle DZO is 10y plus 48, and angle OID is 12y minus 22, and we equate it to 180. We now combine like terms. We have 10y plus 12y is equal to 22y, and 48 minus 22 is equal to 26. And we just need to equate once again to 180. We now once again combine like terms, or by addition property of equality, we have 22y, we just need to copy 22y, equals copy 180. From the left, we transfer 26 to the right, it becomes negative 26. The difference of 180 and 26 is 154. Dividing both sides of the equation by 22, the value of y would be 7. We are now ready to solve for the measure of angle DZO, since we are done solving for the value of y. Angle DZO based on the given is 10y plus 48. So angle DZO then would be equal to 10 times the value of y, which is 7, plus 48. The product of 10 and 7 is 70, plus 48 is 118. The measure of angle DZO then is equal to 118. We now solve for the measure of angle OID. Angle OID and angle DZO, like what I've said a while back, are supplementary. We then have the measure of angle OID plus the measure of angle DZO is equal to 180. Angle OID is the unknown, and angle DZO is already solved, which is 118. We then have angle OID plus the measure of angle DZO is 118 is equal to 180. By addition property of equality or by transposition, we have the measure of angle OID, just need to copy, is equal to 180. Then 118 from the left will be transferred to the right. It becomes negative 118. The difference of 180 and 118 is 62. That's why the measure of angle OID is 62. The two diagonals of quadrilateral ZOID are segment ZI and segment DO. A theorem states that the diagonals of an isosceles trapezoid are congruent. We can therefore say that segment ZI is congruent to segment DO. Let's have examples. If segment ZI is 12 units, then how long is segment OD? Based on the figure, segment ZI is a diagonal and the other diagonal is segment OD. We can therefore say that these two segments must be congruent because the diagonals of an isosceles trapezoid are congruent. We can therefore say that segment OD is also 12 units. We have the second example. If segment DO is 15 units, as you can see, segment DO is the whole diagonal. We have 15 units long. And segment SO is 6.5 units long. Your segment SO is 6.5 units, and that is a portion of the whole diagonal. And we are asked now to find for the length of the other portion of the whole diagonal. So all we need to do is to subtract the portion or the length of the portion of the diagonal, which is 6.5, from the length of the whole diagonal, which is 15. So the difference of 15 and 6.5 is 8.5. Therefore, the length of segment SD or segment DS, which is the other portion of the whole diagonal, is 8.5 units. We have the third example, which is if segment ZI is 4x minus 2 and segment DO is 2x plus 6, let's find the value of x, the length of segment ZI, and the length of segment DO. We now solve for the value of x. Based on the given, we have segment ZI and segment DO. These two segments are the two diagonals of the isosceles trapezoid, which is quadrilateral ZOID. And we have said that the diagonals of the isosceles trapezoid a while back are congruent. We then have segment ZI is equal to segment DO. So by substitution, we can solve for the value of x. Segment ZI based on the given is 4x minus 2 and segment DO is 2x plus 6. By addition property of equality or by transposition, we can combine like terms. We have 4x, copy 4x. Then from the right, we need to move 2x to the left. It becomes negative 2x. And that is equal to copy 6 from the right. Then we move negative 2 from the left to the right. It becomes positive 2. So we now simplify. We have 2x is equal to 8. Dividing both sides of the equation by 2, the value of x would be 4. We can now solve for the length of segment ZI since we are now done solving for the value of x, which is 4. So based on the given, segment ZI is equal to 4x minus 2. All we need to do is to substitute the value of x to the variable x here. So we have segment ZI is equal to 4 times the value of x is 4 minus 2. The product of 4 and 4 is 16, less 2 is 14 units. Therefore, the length of segment ZI is 14 units. We have said a while back that segment ZI is congruent to segment DO. We can then solve segment DO by equating it to the length of segment ZI. Since segment ZI is 14 units long, therefore, segment DO is also 14 units long.